Hey, it's Brad to talk to you about the brightest pulsar that has been discovered in another galaxy, so not even our own Milky Way. So pulsars, or pulsating radio sources, are kind of like zombie dead stars that come back to life and wreak havoc on the universe. Kind of. So when we get a big star, so something about 8 times the mass of our sun or bigger, so our sun is too small, these big stars will explode as what we call supernova. So our sun won't explode, but these big ones do. And I love finding a good exploding star. Except not all of the star explodes. In fact, a little bit of the star, the inside of the star, gets squished down into something we call a neutron star. So imagine you kind of take a scoop of sand and you squeeze and squeeze and squeeze until you can't squeeze it anymore. Well, the inside of the star is compressed so much, compressed into this giant neutron ball. But instead of being the size of a star, you take something about the mass of our sun, now squeeze into something the size of, say, a city, about 20 or 30 kilometers. These are really dense objects. But they're also spinning really, really fast. So now imagine a star spins, our planet spins, everything kind of spins. Now, as that star shrinks down, we get something through what we call the conservation of angular momentum. Imagine an ice skater. They're spinning around with their arms out, and as they pull their arms in, they speed up. So now this star that was spinning, which is now really, really small, starts to spin really, 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 really fast. So now we have this spinning, super fast kind of zombie star. But in some cases, they emit light, or beams of light in particular. And here, everything is light. We're not talking about optical light, we're talking about radio light. So they're emitting beams of radio light. So this kind of acts like a lighthouse. If you imagine a lighthouse is spinning around, beaming out light as that light spins, this pulsar spinning around, beaming out radio waves or radio light. Now, luckily, we have lots of sensitive radio telescopes here in Australia, like Parkes or Murayang. And a student at Sydney, Wan Ming, was looking through data from Parkes and what we call ASCAP, the Australian Square Kilometre Array Pathfinder, looking for signals in our neighbour galaxy, the Large Magellanic Cloud. And this galaxy is about 160 or so thousand light years away. And she found, along with her supervisor, a colleague of mine, Tara Murphy, this source in the Milky Way. And what had happened to appear is that it was 10 times brighter than all the other pulsars we've discovered outside the Milky Way. In fact, could be even brighter than the ones in the Milky Way. So this was kind of a surprise. How is this spinning cosmic lighthouse there, supposedly brighter than a lot of them, but we've not seen before? Well, it's actually quite hard to find some of these stars. There's lots of things happening in the galaxy. You're looking for these really quick, subtle signals, 160 or so thousand light years away. So you need sensitive radio telescopes and some cool software and programming to dig through and find it. And that's exactly what they did. They found this pulsar, which appears to be 10 times brighter than all the other ones that we've previously found outside the Milky Way. So pulsars are a really cool, exciting thing. They're these dead stars spinning extremely fast, beaming light like cosmic lighthouses. And now it may be that we found even one of the brightest ones outside our Milky Way to date. I hope you liked this video. Make sure to like and subscribe and help me make some more awesome science and space videos.